Alright, welcome back. This is part 8, I think, and we are on number 46. We are really getting through these. It's 8:22 on a Friday night, and I'm just sitting here making YouTube videos. Well, whatever. So, you've got... Alright, so this is the first group of problems over sequences and series, what many people think is the easiest thing we've done in a while. So, the first group of problems says, given the general rule for the sequence, generate the first 5 terms, then find the 10th term using the formula. So I'll write down the formula. A sub n equals 3n minus 1. To generate any term in a sequence, given the general rule, which we have, you just plug that number in, and it will give you that term. So if you want to find the first term, you plug in 1 to n. If you want to find the second term, you plug 2 into n, and so on. So we want to generate the first 5 terms of the sequence. So here, you plug in 1 to n. Here, you plug in 2 to n, and so on. So 3 times 1 is 3, minus 1 is 2. So you have 2. And here, this is 6 minus 1. That's 5. Then here, it would be 3 times 3 minus 1. That would be 9 minus 1. That's 8. Now, can we see a pattern here? Plus 3, plus 3. So plus 3 again. Let's see if that holds true. So 3 times 4 minus 1, that's 12 minus 1. That is 11. So this whole plus 3 thing is true for, so far. So I don't see any reason why it wouldn't be still, because it's a linear rule anyway. So then we've got plus 3 again, and that's 14. There's your first 5 terms. Then it says, generate the 10th term. So find a sub 10. So all you have to do there is you plug 10 into 3, or into n. And there you have it. 29. That is a 9. Alright. That looks kind of like a 5 now. I look at my computer and I look back and it looks like a 5. I'm sorry, I'm going to have to erase you. There we go. Alright, that's a much better 9. Got some cosmetic surgery. Alright, so I don't know. I think I'm going to do more than just this set because this is going to go pretty quick. So 47. Go ahead and start over here. A sub n equals n over 2 plus 3. Alright, so you plug in 1. That's 1 over 2 plus 3. 2 over 2 plus 3. So we're plugging in 2. 3 over 2 plus 3. 4 over 2 plus 3. And 5 over 2 plus 3. So this is 3.5. The only time I'll accept mixed numbers. 2 over 2 is 1 plus 3 is 4. This is 3 halves. That's 1 and a half. Plus 3 and a half is 4 and a half. Wow, I feel like I'm back in middle school. So here, well, look at the connections. Just plus a half every time. Boom. So there's our first 5 terms. And the 10th term would be, plug in 10 to n. So 10 over 2 plus 3. And that is 5 plus 3, which is 8. All right, so there are your first 5 terms and your 10th term. There we go. Number 48 is a sub t. This is the first time that our letter has not been in. That's okay though. It doesn't make any difference. Equals 2t plus 1. So a sub 1 is equal to 2 times 1 plus 1. A sub 2 is equal to 2 times 2 plus 1. A sub 3 equals 2 times 3 plus 1. A sub 4 equals 2 times 4 plus 1. And a sub 5 equals 2 times 5 plus 1. I'm actually starting to get a little raspy voice here. Okay, so why did I write a 5? I don't know. Alright, so go ahead and simplify all this out. That's 2 plus 1. That's 4 plus 1. That's 6 plus 1. That's 8 plus 1. And that is 10 plus 1. There's your first 5 terms. Your 10th term is 21. Look at that. Surprise. Surprise, surprise. Number 49, which is the last problem in this grouping, but I've only been recording for 5 minutes, so I think I'm gonna do the next section as well. So you've got a sub r is equal to 3 times the quantity r minus 1. So here, do the same exact thing. Why did I plug 10 in there? Well, because that's the 10th term. So this is 0 times 3. I'm just going to go through here and write these down. So 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 9 is 27. So there is our first, second, third, fourth, fifth, and 10th term. Surprise, we are done. Alright. I think I'm losing some of that peppiness that I had earlier in my recordings. Getting more like worn out here from doing math since 7 o'clock in the morning this morning. Alright, so next we're on number 50, and 50 says it's in the next block, and the next block talks about recursive rules. So it says, given the recursive rule for the sequence, generate the first 5 terms. Alright, so the first one, number 50, says a sub 1 equals 2. A sub n equals a sub n minus 1 plus 3. So what this reads that any term equals the previous term plus 3. That's what this translates to. Right? So if the first term, which they tell you, is 2, right, so that's good, and then any term is the previous term plus 3, then to get the second term, that is the term we're looking for here, the second term is the previous term plus 3. That means it's the first term plus 3, which is 5. Then to get the third term, it is the previous term, which is 5 in this case. All right, so from the third term's perspective, the previous term is the second term, which is 5. So it's the previous term plus 3, which is 8. And then the previous term again is 8 plus 3, and 11 plus 3. Now, maybe you don't buy that a sub n minus 1 represents the previous term. Then you can plug the term value you wish to find in directly, and you will see that it does work. So, just like on the problems above, if you want to find the second term, plug 2 in for n on this problem here, on this formula. So you've got a sub 2 equals a, and the subscript is n minus 1, so that'd be 2 minus 1, then plus 3. Well, that would simplify to a sub 2 equaling 2 minus 1 is 1. And now we're in an interesting predicament, because we use some like math here to get a 1 down here. But when you have a 1 down as a subscript, it doesn't mean like the number 1. This a sub 1 represents the first term, and it's already been stated that the first term is 2. So that is 2. So the second term is 2 plus 3. And that's why this refers to the previous term, because when you plug in your desired term, minus 1, what happens is it's looking for the term right before the term you just plugged in, which happens to be called the previous term. All right, so that's why this works. if you get confused and you forget this is the previous term, but you have like the the instinct to plug in the number in for n, if you do that to completion and then start thinking about what this is, you will get to the answer you need. Right? So, 51. T sub 1 equals 1 half, and T sub n equals 2 T sub n minus 1 minus 1. Now here, the sequence, something I've not actually mentioned at all this year, is that A is not like the only thing that you can call sequences. Like, this is actually like sequence A, where you're finding the first term, second term, third term. This represents the sequence that would be like called T. So it's still a sequence, and the first term is still a half. And then to get the next term, you take 2 times the previous term minus 1. So what is 2 times a half? Well, 2 times a half, and I should have written this down. No, this is fine. 2 times a half is 1, minus 1 is 0. I'll go ahead and write that down over here. 2 times a half minus 1 equals 0. All right, so you got 0. And then you've got the next term is 2 times the previous term minus 1. So that's 2 times the previous term is 0 minus 1. That's negative 1. Then your next term is 2 times the previous term minus 1. That's negative 2 minus 1, which is negative 3. Then you've got 2 times the previous term minus 1, which is negative 7. Now this is an interesting sequence, in my opinion. There's your first 5 terms. 1, 2, 3, 4, 5. So if you look here, I think this is interesting. I'm going to talk about it. If you look here, you subtracted a half. Here you subtracted 1, here you subtracted 2, and here you subtracted 4. I wonder what you subtract next. 8? Are the things you're subtracting increments or powers of 2? Well, I'm just going to do that. I'm curious now. So if you have negative 15 as your next term, this difference, wow, look at that, it is 8. I like this sequence. I made this problem last year. It's a great problem. I'm proud of it. Alright, number 52. A sub 1 equals 4. A sub n equals negative A sub n minus 1. Ooh, this is a... Students are like, wow, what is going on here? Well, the first term is 4. That's literally a given. Your next term is like, so if you plug this in like verbatim here, you'd have A sub 2 equals negative A sub 2 minus 1, which is to say that A sub 2 equals negative A sub 1. So you just take A sub 1 and you flip it. So that's negative 4. So you take the previous term and multiply by negative 1, or just make it negative. So that makes it positive, and then it makes it negative, and then it makes it positive. Wow. Okay, I mean, more power to you. Let's move on. 53. This will be the last problem for this part. P sub 1 equals negative 3. P sub n equals 4 times P sub n minus 1 plus 1. Okay. So the first term is negative 3. There's your given. Then you take the previous term and add 1 to it, and then you multiply that by 4. So you take the previous term and add 1 to it. That's negative 2 times 4, negative 8. Then you take the previous term, which is negative 8, plus 1, that's negative 7. Oh no, I might have to pull out a calculator. This is bad. And multiply that by 4. So negative 7 times 4 is negative 28. Oh my god. And then you've got the next term. Whoops. I apologize. You have to use a calculator here. Unless you just like want to multiply things manually. You know the last time I multiplied more than single digit numbers together? By hand? Oh man. It's been a while. This is negative 27 times 4. So I'll just try to do this in my head. Negative, alright, 4 times negative 27. So 7 times 4 is 28, and then 20 times 4 would be 80. So negative 108. Alright, let's go with that. So then we've got 4 times negative 108 plus 1. Oh my god, why did you do this? So that's negative 107. So you've got negative 400 and negative 28. What in the world? This is a strange connection. Interesting. Negative 428. So close, guys. Alright, then the last term you get well, it's just 4 times negative 400 plus 4 times negative 27, and we know 4 times negative 27 is negative 108. Actually didn't have to, I actually got away with not using any, like, you know, multiplying stuff out. So that's a 0. 0. Alright, so you got negative 1708. If this is wrong, I apologize, but, you know, who cares? Alright, so that marks the end of part, I don't know, it's 7 or something like that. On the next part, we will look at problems 54 through 59, and those are, wow, after me looking at them, they're going to take a while to do. But we will get on that next part. Again, thank you for watching. Hopefully you have learned something, and I am proud of any student who has made it this far. You're doing very good. Keep it up. Honestly, really.